For question number 35, part A,
Mhm.
it's given that side AB and BC. So we are on question number 35. So this is question number 35, part A. And it's given that side AB, BC, and median AD of triangle ABC. So let's say this is triangle ABC, and it has median AD. And there is another triangle, which is triangle PQR. So this is triangle PQR. Okay, now which has median PM, and it's given that AB, side AB and PQR are in proportion, and side BC and QR are in proportion, and median AD is in proportion with median PM. Now we have to prove that triangle ABC is similar to triangle PQR. Now let's make use of what is given to us. So this is side AB proportion with PQ, and BC is in proportion with QR, and AD is in proportion with PM. So let's write down what is given to us. So we have these two sides in proportion. If we are able to prove that this angle is also equal, then the triangle ABC will be equal by the SAS similarity rule. So let's try to get this angles equal. So this is given that AB by PQ. Now, if BC and QR are in proportion, that means half of BC is also in proportion with half of QR, and AB upon P1 will remain as it is. So AB upon PQ. Now, half of BC is BD as well as DC, but we will go with BD. So this is BD, and similarly, half of QR is QM, and this is equal to AD by P. Okay, now these sides are now in triangle ABD and PQM. So triangle ABD is similar to triangle PQM by SSS. Similarity. Okay, if these triangles are similar, that means angle B is equal to angle Q. So B is equal to angle Q. And reason being, these are the corresponding angles of similar triangles are equal. Okay, now let's move to the bigger triangles. So in triangle ABC and the triangle PQR, so it's already given AB upon PQ. So AB upon PQ is equal to BC upon QR, and angle B is equal to angle Q. So therefore, by SAS similarity rule, triangle ABC is similar to triangle PQR. And this solves our question number 35th, part A. Let's move on to part B. And for that, let's try to draw the rough sketch of that. Okay. For part B, question number 35, part B. Okay, it's given that through the midpoint of the side of a parallelogram ABC. So let's say this is a parallelogram ABCD. And let's label it as ABCD. Now it's given that through the midpoint M of side CD. So side CD has midpoint M. A line is drawn intersecting AC in L. So AC is the diagonal. So line is drawn to intersect AC in L, and AD produced in E. So AD is produced, and this line intersects AD produced in E. Okay. Now we have to prove that. So it's given that ABCD is a parallelogram. So ABCD is a parallelogram, and we have to prove that PL is equal to 2 times PL. Okay, so to prove that, so EL, this is EL and BL. Okay, so these are in the triangles. EL is in the triangle AEL and BL is in the triangle ALB. So first of all, let's consider these triangles, and these triangles are BMC and EMD. So the triangles are BMC and EMD. So let's consider these triangles BMC, so EMD and BMC. So in triangle EMD and triangle BMC. Now, for these two triangles, angle EMD is equal to angle EMD is equal to angle CMB, and these are vertically opposite angles. Similarly, AE is parallel and BC is parallel, so this is a transversal. It's also given M is the midpoint, so DM is equal to MC. DM is equal to MC because M is midpoint of CD. It's given that M is midpoint of CD. Okay, now this side we have taken this angle, and now this angle EDM. Angle EDM is also, this angle is also equal to angle BCM because these are corresponding angles. So we can say that by ASA, congruence rule, triangle EMD is congruent to triangle BMC. Okay, once triangle EMD is congruent to triangle BMC, that means that uh, okay, so these triangles are congruent, so that means BC, this side BC, this is C, should be equal to ED. So BC should be equal to ED, so BC is equal to AD, but BC is equal to AD, but this BC is equal to AD. So BC is equal to AD, so that means I can write, so BC is equal to AD. This is because of the corresponding parts of the congruent triangles, and BC is equal to AD because opposite angles, opposite sides of a parallelogram are equal. So these are the opposite sides of a parallelogram. So BC is equal to AD, and that means AD is equal to, that means AD is equal to, so this implies that AD is equal to ED. So AD, and this is AD and this is ED, and these two are equal, and AE is now AD. We can write AD in terms, AE in terms of AD plus AD, and AD and ED are equal. So okay, so AD and ED are equal. So in terms of this AD, I can write BC. So this is AE. So AE is equal to, so AD is equal to BC, and we can write in terms, in place of AD, I can write BC, and AD. So AD is equal to AD and AD is equal to BC. So this is BC. So A is equal to 2 times BC because AD is equal to BC and AD is also equal to ED is also equal to AD. So instead of AD and ED, I can write 2 times BC. So A is equal to 2 times BC. Okay, now we have to prove that EL. So this EL is in triangle. EL is in triangle AEL. So we are going to consider these triangles AEL and the triangle AEL and triangle BL is in triangle BLC. So triangle BLC. So in these two triangles, these two angles, angle L is equal to angle L. So these are vertically opposite angles. Angle L is equal to angle L. These are vertically opposite angles. So in triangle AEL also, uh, any of these angles, so this angle is equal to this. So that is the name of this angle is EAL is equal to angle BCL. And these are alternate interior angles. So these triangles are similar, we can say by AA, similarity rule, triangle AEL. Let's write the symbolic form correctly. So AEL, L is equal to L and A was equal to C. So A is C and CBL. And once the triangles are similar, these corresponding sides are equal. So I can write AE by BC is equal to EL by BL. Now AE is 2 times BC. So AE I can for AE I can write 2 BC by BC. This is equal to EL by BL. This gets cancelled. And if we cross multiply, so from where do we get this? We get this from 1 and this is R1. So we have replaced A with 2BC. So this is 2 upon 1 is equal to EL by BL. And if we cross multiply this, EL will be 2 times BL. So this is what we have to prove. EL is equal to 2 times BL. For that, we first of all prove these two triangles congruent. And from there, we get A is equal to 2 times BC. And then we prove these two triangles similar, and once the triangles are similar, their corresponding sides are in proportion. Replace the value of A with 2BC, and this gives us our desired result. So let's move on to section E, which has the case study questions.